Alright, so today we're going to be solving the funny string problem on HackerRank, which asks us to return whether a string is funny or not. The way we're going to tell if a string is funny or not is through the following. So initially we're given a string s. In this example, it's LMNOP. Each character has a ordinal value, which is a more general concept of ASCII characters. So we know that each character has an ASCII value. Each character also has an ordinal value. Now, regular characters, for example, A through Z, their ordinal value is equivalent to their ASCII value. But some special symbols, like the euro symbol, for example, it doesn't have an ASCII value, it has an ordinal value. So, ordinal values are a more general concept of ASCII values. Anyways, we have a string LMNOP, which each character has its own fixed ordinal value. In this case, L is 108, M is 109, N is 110, O is 111, and P is 112. We need to check whether, well, first we need to note down the subtraction of corresponding values. So, like I said, L is 108, and M is 109. We need to do 108 minus 109, and the absolute value, which is what's relevant to us. We don't care about negatives or positives. The absolute value difference between 108 and 109 is 1. And then we need to move on to M minus N, which is 109 minus 110, which is 1 again. And then N minus O, which is 110 minus 111, which is 1 again. And then finally O minus P, which is 111 minus 112, which is 1. Now note, it doesn't really matter if they're all ones. It could be 1, 2, 3, 4, but we just need to put this array of values aside for now, for the moment being, for the moment. So the next step is to reverse the string. So LMNOP becomes PONML. And we need to repeat the same process. We need to do P minus O, and then O minus N, and then N minus M, and then M minus L. And once we do that, just quick example, P is 112 and O is 111. 112 minus 111 is 1. If you go through this entire list, letter by letter, P minus O minus N minus M, M minus L, you're going to get 1, 1, 1, 1 as well. Since this array of value is equivalent to the first one we noted down for the original string, then the string is considered funny. Now, the reason why it's considered funny in this case is because the letters come after each other, but a case where they wouldn't be funny is most likely if you have letters scattered throughout the alphabet. I think they give an example here, I'm not sure. Yeah, so I believe, there we go, right here. BCXZ and ZXCB. If you follow the process that we went through, B is 98, C is 99, X is 120, and Z is 122. If you subtract each one, you're going to get 1, uh, 1, 1, and then 2. And then if you do this, you're going to get 2, 1, 1, which is not the same. Or sorry, you're going to get 1, 21, 2, and then here you're going to get 2, 21, 1, which is not the same, and therefore they're not funny. So the way we're going to do this is by first we're going to initiate a variable or an integer n that is the length of the string that is given in the function. Let's go back to this example and assume the string is LMNOP. Then what we're going to do is we're going to iterate through this string, but what we're going to do is we're going to start at 1, and this will be evident why in just a second. So we need to iterate through its length. And then we need to obviously increment I. And then the next step is we need to create another integer variable SO, which is going to change through each for loop. And this is going to be equal to math.absolute, because as I mentioned previously, we need the absolute value of the string s dot char at, which gives us the letter at a certain position, the character at a certain position. So s dot char at, where do we want to start? We want to start at I minus 1 because we started our for loop at I equals 1. So for example, s dot char at I minus 1, when I is equal to 1, this is going to take us to I minus 1, which is 1 minus 1, which is 0, which is L. It's important to note in Java most indexes start at 0, so L here is at the position of 0. So I minus 1 will give us L in the first example. And what do we want to do? We want to subtract it by M, which is the next letter. So math.absolute s character at I minus 1. We're going to minus that by s.char at just I. Right? And then we're going to, is everything good? Oh, that's chat, not char. There we go, and then this everything is fine, the syntax is correct. And then we're going to do the same exact thing, but for the reverse of the string. Now, what you could do is you could create a loop to first form the reverse string, but it's tedious and there's really no need for it. You can just scan through your string in reverse. So instead of starting at index 0, you can start at the end, and then go p minus o, and then o minus n, instead of creating a new string that's the reverse of the original string. So, and it's the same thing. Math.absolute s.char at n minus I, and then we're going to do minus s.char at n minus I minus 1, and we're going to close this. And now this is the final step. We're going to check if s underscore o is not equal to sr. And if that's the case, if they're not equal, then return not funny. Otherwise, if this for loop concludes successfully and we exit the for loop, then at no point was so not equal to sr, and we'll quickly go through an example of LMNOP. So if we exit this for loop successfully, then we're just gonna return funny, and make sure you don't forget your semicolons, and that should be it. So let me just clarify on what we're doing. We need LMNOP. Each one has an ordinal value. We need to subtract the letters next to each other. So L minus M, M minus N, N minus O, and O minus P. So what I said is you had to note them down, note down the subtraction of each one, and then compare it to, and then reverse the string, and then perform the same action. So P minus O, O minus N, and then see if they're equal. So we're kind of doing that, but we're checking step by step instead of like noting them down in an array. So for example, what we're doing here, we're checking L minus M, we're storing it in integer SO, and then what we're doing is we're checking P minus O, and we're putting it in SR, and then we're checking if these two values are the same, perfect. If they're not the same, then instantly your string is not funny. So if you want to go through a quick example, we start at I equals 1, so 1 minus 1, that's 0. We established that's L, because obviously index 0 is L. And then I is 1, so that's M. And then we're doing, L minus M, which is 108 minus 109. And Java automatically, since you're using the math.absolute function, Java will automatically perform or convert these characters, because s.char at returns a character, will automatically convert it to an integer type. So, and it will convert each character into its ordinal value automatically. And so we get L minus M, which is 108 minus 109, which is 1. And then we're going to check the reverse string. So we're checking at index, so n is the length of the string, 1, 2, 3, 4, 5. 5 minus 1, which is 4. And remember I said all indexes start at 0. So 0, 1, 2, 3, 4, we're at P. And then if we minus 1, we're going to be at O. So we're doing P minus O, and we're going to get 1. And then we're checking, is 1 equal to 1, or is 1 not equal to 1? That's not the case, so increment I and keep going. And yeah, that's the funny string problem. Let's submit, see if it works. We probably have a syntax error. Yep, hold on. Let me just fix that. Boom. Reset this code. And then, there we go. Let's test again. There we go. Yeah. Thanks for watching.